How's it going, everyone? Vlad here, and welcome back to the channel. Today we have a very interesting, very special video for you. So if you haven't seen already, there was a video that I posted on safety circuits and a general theory overview of what it takes to implement as well as troubleshoot safety circuits. Underneath that video, there was one question that I did want to address, which was to showcase a real machine and the safety circuits associated with that machine. As you can imagine, there's a lot of NDAs and it's very difficult to share actual diagrams of machinery. So a friend of mine was very generous to provide the diagram we're going to look at today of a machine that he has worked with. And so without extensive knowledge of this specific machine, I'm going to give you a couple of my comments as we scroll through the PDF and basically understand what kind of safety circuits you would expect in the field, how you would troubleshoot them, and ultimately how do you bring this back from the theory aspect to the actual field. Why is this important? Number one, if you're doing any sort of purchasing of such machines at the plant level or at the corporate level, you would want to review the type of safety, but also the type of circuits you're getting, the type of control systems you're getting. Number two, you want to understand how to tie this back in at your site. So obviously you need a team of engineers and techs to be able to do the VAT, the SAT or the FIT, depending on how you proceed with those types of activities, to understand how to tie this back into your production systems. So you need to be able to make decisions as the contractors or the machine builders are executing this specific machine and be able to negotiate or at least have the conversations and be able to ask certain questions as you review the diagrams of their specific machines. Of course, there's going to be some nuances. There's going to be companies that own their machines and their prints. There's going to be companies that do not own and have absolutely, or I want to say, little say in what the machine is going to contain. We're going to talk about all of those use cases in generalities, but of course, if you have something different in mind, don't hesitate to leave us a comment, don't hesitate to reach out, and we can look at your specific case. That being said, without any further delay, let's take a look at what we have. So here we have a machine. This is the first page out of 197, so quite an extensive set of prints, which is called Le Safre. It is a bagging machine, as you can see by the title. If we start scrolling down, we can immediately see that this machine was made in Italy. So there's going to be a portion of the drawings that will be, of course, in Italian. That being said, we start off with a very important page, which you usually be included in every set of drawings. That is the table of contents. So here we can see a variety of different devices or different systems or subsystems that will be included in the prints. And as you can see, all the pages pretty much are going to be labeled with some sort of a use case. So I do not want to cover all of these circuits in this specific conversation, but we're going to focus on the safety side. We'll review some of the power circuitry on the initial pages, but ultimately we want to get to pages 13 through 22. As you can see, this is push button safety management. There's going to be some door safety management, and the goal is to, like I said, discuss the general setup of safety on a machine that we are not particularly familiar with, and give you some ideas as to how I would approach troubleshooting, VATing, or basically negotiating and having some conversations and comments about the way they've designed the safety. So we're going to scroll past all of this. We're obviously going to be met at the beginning with some of the mechanical drawings. Again, if you're on the mechanical side and maybe you care about some of these designs and you care about perhaps the HMI that they're using, you can have conversations on that side. We're going to scroll past through this, and immediately we're going to be met with some of the safety circuits that we discussed in theory in the previous video. So as you can see here, it is labeled in Italian. It says emergenza, but as engineers or as managers, you should be able to read past through this and understand that this is your very standard e-stop push button that will light up as it's pressed in, and it will turn off as it's pulled out. And so at the very core of safety circuits, as I had mentioned in that video, you're going to have dual channel safety, and it looks like they're doing this properly. So here you have two channels going through the e-stop. I don't know how well you can see this. Obviously, I'm using my mouse a little bit to point, but basically every single circuit is going to have a dual channel setup. you will notice that there's going to be single channel setups, and those are usually going to be your reset push buttons. And I don't know how well we can see it. If we can zoom into this specific push button, I'm assuming that Resty Bill A, this is going to be some kind of a reset for that specific circuit. Once again, it is labeled as the wear push button panel. We're going to, like I said, do our best to decipher the safety circuits, but at the end of the day, if you have the machine in front of you, you should be able to go and trace out the wires that are going to be labeled in this specific schematic. So don't expect us to be able to do everything from this specific PDF. Next, we have all the push buttons. So here we have the emergency push button, and I'm going to zoom in just because we can read a little bit better. This is simply the rendering of the PDF as it was delivered to us. You will see that there's going to be a general start generale, and obviously you have the wire labels on both sides, the start, the stop, as well as the light, I guess, of some kind, or some kind of a relay, is going to be a single channel circuit, while once again the e-stop is going to have 2 channels. We have an automatic start, we have obviously some indicators, we have stops that are normally closed with the starts that are normally open, exactly as you would expect in a very traditional circuit, not only on the safety side but also on the general purpose side. We have the specifications of the dimensions of the panel. That's not something we're going to spend a whole lot of time on. Here we have a very important drawing, which is going to be basically the layout of your panel, and so without obviously seeing it in front of us, we cannot imagine the general circuitry layout, but we can get a glance as to what it's going to look like, or what it already looked like in the field. We have a PLC, we have your terminal blocks for 24 volts, we have some fuse blocks. I would assume you have 110 somewhere in this panel as well. We're going to see a power block, there's some transformers, there's a lot of fuses. We have a PowerFlex set of different drives. The 527, it's actually a newer drive in the series. We have some cards over here, which I'm assuming is digital inputs and outputs. We can obviously look up the part numbers that are listed here to figure out exactly what they are, but in a general sense, we're going to scroll past through that. As you can see, there's going to be a lot of wire labels and where everything lands that's going to be used by your techs and electricians building the panel before it hits the production floor. Of course, you have labels as well for the distribution of your channels. As I said, something very interesting if we wanted to dive a little bit deeper on that side, but we're going to scroll through this, and I'm going to wait a little bit for the pages to load. It looks like there's going to be some safety channel specifications as well. And until we find something a little bit more interesting. So these are very standard labels. So if you were to print this out, or if you had your panel shop print this out, these are the labels that will be applied to the terminal blocks. So here we have the initial channel, which is going to be the 3 phases coming into the machine. And so again, if we zoom into this to see a little bit better, because the wording is not rendered correctly, you'll see that you have a Rockwell automation, some kind of an NFPA rated disconnect. Obviously, you can find the exact part numbers if you desire to do so. It is a breaker of 125 amps. This is where you would feed your 3 phases of 480 volts, 60 hertz, as you would expect in the United States. It goes through some kind of a, again, like blade disconnect. There's going to be a fuse block as well, I believe, in many of these areas. We're not going to spend a whole lot of time going through this circuit specifically, but you can find all sorts of different parts if you're looking to get into more on the 3-phase management side of electrical diagrams. So here we have very interesting devices that are going to be your transformers. As you can see here, we're going to tap 2 different transformers. The reason why, obviously, it is unclear for now. We could always trace back where this goes, right? So there's going to be different pages indicated on the drawings as to where the circuit is going to continue. And this is a very important reference, especially for newer engineers that get caught up in troubleshooting some of this equipment, or, like I said, commissioning some of this equipment. You'll notice that there's going to be this 9L2 label, but ultimately it goes to page 3 and 11L1 page, label that goes to page 95. So by using these references, you can basically jump between pages to understand what the circuit is doing. And so the pages are also going to be different from the PDF of the pages, and this is a trap for, again, younger engineers, because you have a label of your sheet at the bottom. So this is sheet number 2, so it is not page 3 of the PDF. Right now we're on page 22, but it is the sheet number for this specific drawing. So depending on how this was assembled, different groups are going to work on different areas, and then you're going to basically merge the electrical as well as the mechanical or the process sides of your drawings. And so it's very important to pay attention to the actual label of the sheet when you're going through these drawings. But basically, this is going to be, if you see my mouse here on the top left hand side, where those 2 wires come in from the transformer, and you'll immediately notice a couple of things. There's going to be some fuse blocks, there's going to be some terminal blocks, there's of course going to be some disconnects that you see here. There's going to be a drawing of a provide new fuse holder, so it sounds like somebody wanted to add an extra circuit to this specific set of 110, I believe, was the label here. So there's one that's going to be 110 or 120, and one that is 230. So in this case, it's the 120 line. And as we continue to scroll past this, you'll see there's going to be a tap on the 3-phase filter side. So I'm assuming this is going to go to your VFDs or motors. Again, I'm not going to explain every single detail about the schematic. We're going to have, this is actually a very good attention to detail. So some of the terminals, and if you've worked enough with the Rockwell system of wiring some of those cables, very good addition to the prints, because it sets up a reminder for someone who's wiring a lot of those circuits. You're going to see some different manufacturers as well. So this is Wedmuller fuse blocks. We're going to scroll past this, blank pages, perfectly normal to expect. There's going to be neon on switchboard. I'm not sure what that is referring to. It could be a cabinet light, for example. So this is our first power, I want to say, set of prints that is going to come off this 24 volts DC. So we have your Compact GuardLogix, and once again we can zoom in just to see the labels a little bit better. I'm not sure why the PDF is not rendering, but it is a 1769 L33 ERMS. So you will immediately notice a couple of things, and this is not something I would expect, I want to say, early career engineers to understand. This is a Compact GuardLogix, as the name indicates. This is also a motion controller signified by this M right here, but it is also a safety controller. So this is going to be a panel which will use or drive safety through the PLC. So this is a programmable safety type of an application. We're not expecting to see safety relays as I had demonstrated in the previous video, but rather a programmable set of contacts which will obviously dictate how the layout of this panel is going to look like. And so as I continue to scroll through the drawing, we will see a safety circuit here, and this is going to be your emergency circuit safety channel 1 and channel 2 inserted. So basically we have a push safety stop, and you will notice a couple of things here immediately, right? So as I look at this safety circuit, it looks like they have 2 sets of contacts that are short-circuited with this little bracket in between them, and for me that indicates that this machine can be tied into something else once it comes onto the plant. And so what is an example of this something else? Well, the example could be is you have a machine that's part of a line where the e-stop needs to be located maybe at the start of the line but also at the end of the line in a common safety stop circuit. So this is not going to be one of those applications where you hit the e-stop at one machine, then you have to run to the next one to hit the e-stop, to the next one, to the next one. Maybe you want to make this part of a chain, and so this is where you would insert some of those contacts. And so if any of those contacts are broken, this machine is going to be basically e-stopped. So this is a very nice touch. I don't see all of the OEMs or machine builders include something like this. And as you have conversations with machines coming onto onto your floor, you definitely want to do a risk assessment and understand how your personnel will have to modify the equipment in order to meet the safety standards of your facility versus what the machine builder has built for you. And of course, they cannot account for all the scenarios on their side because they're building a system that is part of a line, but they don't know what the actual entire line might be. So here, as we continue to scroll past that initial e-stop, we'll have two more e-stops here. So this is going to be a push button panel emergency circuit, channel 1, channel 2. Once again, very standard. There's going to be 2 channels for every safety push button. And again, if we look back at this X5P and X2P, I believe we had the actual name built into the labels at the front of the drawing, but we can see that this is a bag magazine emergency circuit, so channel 1 and channel 2. Now, the pause here that I want to make and maybe take a step back from the previous video if you watched it, is that here, once again, you're using safety based on the inputs and outputs of your PLC device. So you're not seeing the same circuit that I had described with the safety relays, where you basically have a safety relay with the two channels and daisy chaining all of the devices, the e-stops, the light curtains, etc., etc. This goes back to your PLC safety I/O because it will be programmed as such. So once again, here we see the continuation of the safety circuits. Once again, dual channel on all of the e-stops. It is important to pay attention to this. If you bring in a machine that is going to miswire some of these circuits, and I've seen all sorts of different things. For example, it goes through the e-stop and then this wire comes out and comes back into the second terminal and then basically hits both channels that way. That is not proper safety. So you want to make sure that some of your engineers or even managers review these drawings and understand what is going to be placed in the field. So at this point, we have some specialty connectors. Again, this is, I don't see what the manufacturer of this specific connector is. This is some kind of a mass disconnect for various I/O on this specific machine. We're not going to spend a whole lot of time there. And basically at this point, we no longer have the safety side, but we're going to have a lot of the different very standard I/O. So I scrolled past this a little bit, but as you can see here, this is the disconnect that you had on that massive connector. So there's going to be some door feedback, there's going to be some sensors. You'll see that it comes in on the normal input 15.7/0 channel. So this is, I would assume, some kind of a card 15, and this is going to be input 0, input 1, input 2, so on and so forth. Of course, there's going to be a whole lot of conversation to be had on how to diagnose and troubleshoot problems on the electrical side. That being said, we do not want to spend a whole lot of time on that side. I did want to mention, so this is something we're getting into right now, all the other push buttons and all the other signals that are not safety rated are going to be on a single channel. So here, as an example, you have a start as well as the stop push buttons, and one of them, as you would expect on the start side, and this is again theory of controls, we're not going to get into those details, but they all have a single wire going through them, and that is to be expected for a non-safety rated application. So this is going to be it for this video. If you have any specific questions when it comes to this drawing, don't hesitate to reach out, don't hesitate to leave them in the comment section. What I really wanted to demonstrate is that as you get into some of these safety applications, you need to get in the habit of reviewing what are going to be the safety components of your machine. You need to be able to have conversations about the miswiring in certain cases of your machines. You need to be able to make decisions on how that machine is going to be integrated once it hits the plant floor. And ultimately, you need to be able to be comfortable to troubleshoot and VAT or commission some of this machinery, because you're going to be, if you're in a management position, you're going to have to send personnel to go and validate some of the circuitry. If you're an engineer, you're going to have to put a meter to a lot of these devices, as I explained on the theory side. So you should be able to pinpoint where you should have 24 volts at what specific time, what kind of disconnects does your safety circuit provide, and basically you need to have a general understanding and a general, I want to say, channel of communication with the vendor as to what they're providing as far as the safety goes and how it's going to have to either change or be modified once it lands in your specific facility for your specific case. Thank you so much for watching, and like I said, if you have any questions, don't hesitate to reach out.